In version 2.0 of C Sharp, Microsoft introduced something known as generics. Generics are a concept for allowing you to define type-safe classes without committing to actual data types at the time that you define the class itself. Now, generics help you to maximize code reuse, type safety, and performance of your application. As an example, in previous types of collections that were non-generic, you could store objects or different data types within some of the collections in the .NET framework. And then to use those objects from that collection again potentially meant that you had to deal with boxing and unboxing, which references really the casting of an object to a specific type. That exacts a performance penalty on your application. Instead, what we can do with generics is we can defer the type that we're going to use with that class or with the collection until we actually use it. And so we can create general purpose collections using generics that perform much better than the non-generic type collections. And we'll see examples of those here in a moment. Generic-based collections actually store objects of different types as they're already defined in the type that they represent. That statement maybe is a little convoluted and complex when we think about it in the abstract sense, but we'll see an example of it here in just a moment. So what I've done is I've implemented the system.collections and system.collections.generic namespaces through my using directives in this C# program. And as an example, one of the collection types that we could use before in non-generic type collections was the stack. So this is a collection type in the .NET framework that represents your last in, first out type of collection. And consider it similar to a stack of plates that you might find in a cafeteria line, where the first plate that you put on the stack ends up being the plate that's at the bottom, and then all of the rest of them get put on top or stacked on top of it. So if we were to create a stack and just call this one my stack equals new stack, and then we can actually go through the process of adding items to my stack. So we can go my stack.push. Push is the method that actually adds an item to the stack itself. Push.add, and I'm just going to throw in a text value here called a string, and the stack says, yeah, that's fine, I can store that on there. My stack.push. In this case, I'm going to put the number 34, and the stack says, no problem, I can throw that on there as well. It's a piece of cake. I can deal with this one. And I can even go my stack.push, and maybe I want to throw another stack on here. Who knows? I mean, I can throw all kinds of different objects and stuff on here, and it's going to complain about this because I haven't instantiated a stack. But, as an example, we could even, let's throw my stack on here because it's a stack object that's already instantiated. This is perfectly legal in C#, and we can do this, but what's going to happen is if I want to pull the information out of here, so if I execute a mystack.pop statement, I'm going to pull the first item off the stack. Now, because stacks work in reverse of when we push items on, I'll actually be popping my stack off. And I don't specify anything. I just simply say mystack.pop, and that method will pull my stack off. But if I wanted to use that in another variable here on the left-hand side for an assignment, I would have to check what kind of an object it is that I'm pulling back from this stack. And that becomes a little problematic from the performance aspect and the code that you have to write to check for that type of object that we're going to pull back. So it becomes an issue when we're using the non-generic types. Instead, what generics allow us to do, you'll notice that you're dealing with the generics type because of these angle brackets. And we look at, the definition for this system.collections.generic.stack, and then we have T. T is what's known as a placeholder. And the placeholder is what we use to declare or define the type of object that we would actually store in the stack as we start using it. Let's go ahead and create a new version of this stack. And what we're going to do is declare this one to be of type string. So we replace the T placeholder with an actual data type. So we're going to call this one string. So we're going to say str stack. So this one becomes a string stack, and this equals new stack string. And you notice how the IntelliSense automatically knows that I've created string as the data type for this new stack. And it allows us to create this new generic type of a stack. Now, where the advantages from generic come into play is if I attempt to do str stack dot push, and I attempt to put in a string, that is perfectly fine. C# allows me to do that. What happens if I attempt to push something else on here, such as the value 34? And let's see what takes place. Well, right off the bat, C# is complaining because it's saying, hey, wait a minute now. The best overload method match for the push method that we're using is saying it's looking for a string. And you'll notice that in the syntax in the error message, because I have declared my stack to store types of string. So you might think that this is restrictive. In other words, saying that, well, what if I wanted a stack that could store all kinds of objects? Well, if you do, don't use a generic stack, come back to using a standard stack. But you're going to deal with all kinds of performance issues because of boxing and unboxing or casting value types, object types to a specific value type back and forth. And you don't want to do that in your code unless it's absolutely necessary. Here, we're just saying that we've created a stack that will hold instances of string values within it. And so that's basically what generics allow us to do, is it creates more type-safe code, more type-safe application. And this is, if we take a look at it from the perspective of how we've declared this, this is really self-documenting. Stack string tells us that this stack exists to hold a bunch of string objects that we would have. You can make no mistake when you're using it, you know exactly what it is that you have to put into that. A very quick introduction here to generics. Again, think of generic classes as the ability to provide you with type safety, code reuse, and greater performance in your application. You use them mostly with .NET collections because they don't require those casting operations. So that's primarily where you're going to make use of generics in your application. And go ahead and take a look at some of the .NET framework samples and libraries that use the generic types, use the generic collections, and see how it makes the readability of your code much more obvious when you're looking at generic types of collections as opposed to non-generic types.